Good afternoon, good morning, hello everybody, and welcome to the latest in our series of Mobile Mapping Essentials webinars. Today we're going to have a look at mobile mapping and telecom projects. We've had quite a lot of interest from the telecom community for our mobile mapping systems, so it seems like a very timely subject to cover. And our presenter today is Marco Bello, who's our technical sales engineer based in Italy. And welcome, Marco, and I'll hand over to you.
Thanks, Pete, for the intro. Thanks everyone for attending. Good day to everyone. Today we will touch this interesting topic about fiber to the home applications, fiber optic in general. You, Pete, already introduced myself well. I am a sales engineer based in Italy for mobile mapping in the region, and it's almost 20 years now I'm in the company, and since 2013 I'm just looking after the mobile mapping market from an hardware and software point of view. This is the argument I would like to touch during this presentation. I think I'm anticipating around 1 hour. At the end, we will probably have a question and answer time to go deeper whenever needed. And in this presentation, I would like to describe a little bit what is in general a fiber to the home application, fiber project, how this is deployed, and how mobile mapping technology, from a data collections point of view and from a software processing point of view, how mobile mapping can help for the realization of these projects. And I want to touch also a little bit of the two of the office software solutions which we do provide, which I think are pretty well aligned to support this mobile mapping application or these telecommunication applications. And in general, I start from the assumptions. The assumption I do here is that as soon as I will explain to you the application itself, I'm pretty convinced that immediately you will understand how mobile mapping technology can help in these applications. I'd like to start with what is a fiber to the home application. So which application is that? What this is all about? In general, fiber to the home is a fast way to provide access to networks. It could be fast access to information, fast access to streaming services, broadcasting services, but that's not just that. It's fiber to the home is much more than that. Basically, it's also a technology which is opening to a wide range of possible services and opportunities which are making use of this infrastructure. So it's not just the internet itself. Just as an example, we hear in the monitoring world, people also start talking about fiber sensing, where the fiber optic basically consists of a sensor itself, which can be used to investigate some events. For instance, here in Italy, there is a running project where the fiber optic network is also used to kind of have quite fast monitoring of earthquake events. So this is just one of the possible applications which can also make use of the fiber optic. Where are we today with the deployment of this of the fiber optic networks? Well, that's a slide from the Fiber to the Home European Council, which happened in 2020. And from here, basically, you can see the coverage of the by country of the fiber optic network. And in general, what is interesting here is that they say that more than 50% of the homes of the inhabitants basically are covered by the full fiber, which means, what does full fiber means? The fiber optic technology, or FTTX if you like, can be splitted in different kind of broadband communication services. We talk about FTTH, which stands for fiber to the home, which means that the fiber optic network providing connectivity arrives directly to the router of the user. We talk about FTTC, which could be fiber to the cabinet, where the fiber network cable arrives to the cabinet, and then from the cabinet we have the typical copper cable going to the house of the user, with the consequent losing performances. Fiber to the premises, fiber to the radio, where the last mile might be covered by a radio link from the fiber optic cable directly to and then to the home of the user. All of this belongs to this FTTX, if you like, concept or terminology. And slightly more than 50% means that there is still a lot of work which has to be done. This is just a table from Europe, but probably the scenario is pretty much the same on the other parts of the world. How the fiber optic network, typical fiber optic network looks like. We have different, let's say, components or elements belonging to such a utility network. The main one is probably the national point of presence. So imagine that in a country, you might have a small number of these national POPs, which are kind of control centers. For example, I think in Italy, we have 3 of those covering all the country. And that's basically the core. That's basically where the network is managed and is controlled and services are distributed. From the national POP, then we go to more localized POPs, could be a number of those per city, POPs by districts, and which are basically generating the connection or creating the connections to the houses or the buildings of the end users. And from the POPs to the houses or to the buildings, then you have a number of splitters, online optical splitters, which are basically distributing the network all around the country. And what is kind of interesting is that to each of these splitters, we are not facing any kind of reduction of the performances, because in here, basically, we are just splitting the light, right? And that's basically it. We are just redirecting this to the final destination, which are this optical network terminal for a number of buildings, or the optical network unit in case we are reaching out a specific house and a specific family. Now, there are this said, which are the steps which need to be considered when a company is working on a project to deploy such kind of utility. This is consisting of different steps, which you can find listed here. We have the walkout phase, design phase, deployment, restoration, and services activation. Let's quickly have a look to these different steps. Before designing a new network, is quite important to establish what's available already on site, which buildings have to be reached, which houses, which offices, which services has to be reached with this utility network. It's also important to know what's already available, what's already existing, because might be the case that some already existing sub-services might, for example, host the passage of cables for the fiber optic. So it's important to know what's already available on site. And according to this scouting or this walkout investigation, then it's possible to estimate, okay, which are the permissions which might be requested in order to be able to start digging a new trench, and maybe connecting, making use of some specific poles or things like that. So this kind of investigation a priori is what is called the walkout, which in general consists of a quite detailed mapping activity. Once these informations are reaching the office, then there is the chance to start working on the project definition. So understanding according to where the line has to be installed, which kind of trenching activity has to be done. Maybe the dig approach, the no dig one, maybe using on-the-air cables, and then which kind of approvals are also needed in order to be able starting this on-site activity. So all these activities can just start as soon as there is a clear idea of what's available out in the site, which has to be covered by the fiber optic. Once the project is ready, then the activity on field can start. So maybe the point of presence are realized. Imagine you might have kind of big rooms or offices where you might have similar to server rooms, where all these cables are starting from the main line to starting to be distributed all around through the cities or districts. And the cables are then installed, making use of fresh new trenches, for example, or as I said earlier, maybe making use of already existing sub-services. An interesting thing is that the fiber optic cable is basically a dielectric element, so there is no absolute problem in making use of the same small pipes for electricity cable and fiber optic cables. That's why it's quite important to know which utilities are already available. And by the way, sometimes companies in charge to do this kind of operations sometimes are combining mobile mapping together with GPR technologies in order to understand which possible sub-services are available in the areas where a network has to be installed. Once the cable has been installed on the ground, everything then comes connected at the control centers, and then it's possible to start doing some tests on the performances of the network itself before maybe starting offering the services via contracts to. Once the network has been installed, of course, when the construction sites are closed, the subcontractors need to make sure that the road or the area interested by the excavations are exactly in the same conditions as before. That's quite an important part. Contractors have to take care of, avoid having holes on the road, or problems in general for the vehicles or for pedestrians. So this situation has to be absolutely fixed and mapped at the same time. So in order to have clear documentations about the condition of the site once the on-site activity and the construction site has been closed. And this also is kind of consisting in a kind of mapping activity and documenting activity, for example, also via imagery, why not, of the condition of the site after the final step is, of course, the services activations when all the lines are started, contracts are signed by the end users to sign it together with the specific which has been identified. Now, this in general as an explanation of the application or what fiber to the home stands for and what the fiber optic application means. Now, let's try to see where the mobile mapping technology is helping, who is in charge of designing and realizing a utility network for fiber optic. So this is the schema we have just seen earlier about how a fiber optic network would look like. And at the control center, at the national control center of our point of presence, imagine you have the main line starting to be, the main connection starting to be distributed all around in the country. And this is where at the national POPs, this is also the location where the services of the network itself are constantly monitored by the operators. And you have databases with the users, location of the user, the building, number of the building, identifier of the buildings or the houses, and everything is kind of hosted, or let's say differently, all this kind of technology is also supported by quite powerful GIS platforms, I would say, where all this information is controlled, is managed also graphically, and from where the operators can see in real time whatever issues might happen in terms of connection issues, problems with the line. And so the GIS platform is an important tool which is used by the operator of such kind of utility at the control center level. Additionally to this, who is getting the contract to build up the network, installing the lines, the cabinets, manholes, and all the assets which are needed for this kind of utilities. They need to know what's on site, as I said earlier, which sub-services or services in general are already available, which assets are already available, which could be used. So to reduce maybe the impact of a construction site, to reduce maybe the cost of deploying or installing new, maybe not necessary assets. So they need to know where they have to dig, where they can actually dig, where they are allowed to dig. And that's where, for example, GPR can help in understanding where maybe there is some other utility which is just crossing the line you have from your design. And it's important to know which material you have to dig in. Do we have to open a trench on a concrete, on a asphalt? Is this verge? Because according to the material, which the operator of the machines can find on the construction site, of course, any kind of operation has got a specific cost according to the material they have to work with. And so it's important for them to have some tools to quantify the cost of these field operations and quantify the cost of the material which is needed. So all this kind of planning activity may benefit of the mobile mapping technology, which can really speed up the collection of informations for the realization of the following up projects. This is exactly what I was showing in the two previous slides. So from one side, we have the network provider who is interested in managing, controlling the installation, the utility network itself, making use of possibly this GIS-based platform, databases of users and databases of performances on the network. On the other side, we have who is in charge to do the job with the machines going to the field and maybe collecting information and then physically opening trenches, installing the cables, and perform all the set up all the required cabling activity. Now, if we look at the data collection part, if you like, there is one part of this which could kind of consist of a mapping grade or kind of activity, GIS, if you like, activity. And that's basically the part where all the existing sub-services and other services are mapped, or maybe assets in general are mapped on the road or on the area where the fiber optic cable has to pass through. And in some cases, imagery documentation could be enough. Maybe imageries from where you can also do some measurements. And we have, by the way, some cases of some customers here in Europe making use, for example, of our Trimble MX7 system to document, but also to extract informations to feed the databases, which are needed to strategically do the computation or the analysis of the cost of the utility deployment. And this information is useful for this investigation or scouting or walkout part of the process, if you like, but are also information which are useful to build up the GIS ecosystem, which is hosted in the national POPs, where the control center are of these large utilities. Some other customers, some other users are not just making use of the imageries, but maybe they also want to benefit of the geometrical information coming maybe from the point cloud, for example, from the Trimble MX9. Because with the point cloud data, beside the fact that they can also benefit of imagery, maybe they also would like to understand how much material has to be removed from the site, how many trucks will be needed to move this material somewhere else, and how deep will be the trench, how much material will be needed to fill in the trench as soon as the cable has been installed on the ground. And this is operations which are much easier when you have LiDAR information, when you have quantum information. And so in general, for mid to big scale projects, is much more efficient to make use of mobile mapping technology instead of sending operator with maybe handheld devices or maybe surveying equipment to collect all this information. That's definitely safer, and that's definitely faster to make use of mobile mapping technology. Now, I would like to show you that was the part of the data acquisition, making use of mobile mapping. 7 customer demo MX9 specific cases. Let's see then how this data, the data collected by this mobile mapping platform, how this information is going into inside our Office software. The first software here is a Trimble MX, and which is very useful for example, for the planning of your fiber optic network project. As I said, with the image only based or point cloud also based data set from the field, TMX is possible to display the mobile mapping data and point cloud and imagery. And then you can do your measurement, or you can do your feature extractions directly from your mobile mapping or from your imageries. And making use of these measurement tools, actually you have the chance to digitize, create your line works. For example, the line representing where the fiber optic will have to pass, maybe representing the location of the trench which has to be opened for the fiber optic. Maybe some already existing databases of other services is available, and then in TMX you would have the chance to connect to already existing database of some assets, for example, telephone or electricity, and so that you can optimize the design of your network according to already existing utilities in the field. And I just want to quickly show you how the data set could look like inside the Trimble MX. This is Trimble MX, the asset modeler software. Inside here, I have just loaded MX9 dataset. Here you can see we have the spherical imagery of this road. Let's assume we want to build up, need to have to open a trench on the right-hand side of the road. And on one hand, we have the imageries which are helping us in documenting the site, but additionally, we also can benefit of the geometrical information coming directly from the point cloud. So making use of the point cloud, we can very easily create our layer, for example, of fiber optic trench, for instance. Then we can start digitizing, and we could create all our line works. We could mark where we have to install the different kind of manholes, where we might have to install some optical splitter, for example. We can collect information of the length of each lines and then specific attributes of the other elements we have to install of the manholes, for example. Here we have the 3D view where you can see I've been digitizing the point cloud in this case, and as a label attributes I have the length of the line I was just drawing, and each element, line on manhole, can be characterized with some attributes. For example, if I select the trench layer and then I can make a selection on the specific line, from the lines you have direct access to the information or the attributes of the layer which was created, for example, which is the material where the operator will have to dig to establish the trench, which is the length of this segment. And according to the length, of course, the following up analysis could be which would be the cost to dig in such material and for such a length. And then why not, which is the digging technique which has to be applied for the specific material we have to dig. And these attributes belonging to the, in this case, to the FTTH trench I created, I was creating this manually, but as I said earlier, having an already existing layer in a database with such schema in TMX, it's very easy to establish a connection to this already existing database and make use of the same maybe attributes in order to be able to display those in my fresh new mobile mapping data. And why not maybe also updating or editing those based on the new mobile mapping data I'm just importing in the software. So this is the case of the line, but very similar to this, we could also make inquiries to the manholes features which are available, and also in this case we can have a look to the type of manhole. Is this a feed? Is this a pool? Is an intermediate pool for the cover for the fiber optic cable pulling activities? Which is the size of the manhole? So all attributes which can be created or again just imported and used, and all of these being part of basically the design for the future for fiber optic network. And all this information, as all these extractions which are done directly by the operator in TMX, can be directly linked, for example, to Esri-based GIS platform, to QGIS platform, so that the information extracted here can go and feed the data management ecosystem of the utility provider. Okay, I go back to the slides. This was about the Trimble MXD asset modeler software. And now I just quickly want also to show you Trimble Business Center with the utility module. The Trimble utility module of Trimble Business Center provides you a step-by-step workflow, which is covering from the definition of the materials and the assets which you might need or you might find out in the field, up to the creation of the geometry of your network, the editing of the geometry and the elements of the utility network. And at the end, the utility module helps you also in generating a possible trench according to templates the customer can customize and create. And all of this basically can be finalized in the generation of a final report where the user at the end can see the extent of the trenches, the volumes of the materials which have to be removed or moved, the number of elements which are needed, for example, manholes, type of pipes, diameter per type of pipes, and And all of this information is kind of archived in a kind of database. And at the end, you can have a report. And if the cost of each material is also available, you could really have an estimation of the costs which the subcontractor have to cover in order to open this construction site and finalize the creation of this utility network in field. First tool which is available in utility module is the Material and Site Improvement Manager. And with this tool, the operator has the chance to create a library, for example, of material which will be found out once on site. So material, for example, where we have to dig, for instance, and also where the operator have the chance to build up a list of items, of tools, for example, as well, or could be assets like manholes on pipe, which he can pick from and use when building up the utility network. So basically, that's a kind of library which the operator can customize and save and maybe share with other division of the same organization, maybe working for similar utility project, but in different sites. Once the material and the assets has been defined inside this utility library, Trimble Business Center offers the tools to start digitizing on the point cloud and positioning maybe the manholes, primary, secondary manholes, and then connecting those manholes with the specific pipes created in the library, from the library. You can see here that we have some creation tools to start connecting all the different elements of the network. And then we also have some editing tools, enabling the operator to change some elements which were previously installed on there. Once the utility network has been designed, the operator also has the chance to create a template for the trench. And inside each trench, it's possible to create a kind of template profile, providing information of each layer of the materials which will be present in the trench. And for example, why not, creating also some layer of the materials which will be utilized at the end of the construction site in order to fill in maybe the trench itself. And each layer with its own features, geotechnical characteristics, and why not even the cost for the material, so that this tool can be used to generate at the end a detailed report telling you which material was used, how much, the value of this material, so the cost for all of these operations. So all of these steps again belong to the kind of workflow step by step which the users in TBC has simply to follow up. At the end, it's possible to compare the trench itself design can be exported as a mesh basically, and this element, this 3D element, can be compared, for example, against a terrain model of the surface of the road, and by doing simple volume comparisons is possible to establish, is possible to get the information of the materials which have to be moved from the site or have to be positioned on site. And I just want to show you quickly TBC with the data set I was showing in making use of the slides. This is again MX9 data set. This is a small village here in Italy. Maybe let me just change the scale. Maybe like and here, starting from the mobile mapping module, point cloud has been produced, has been generated, In this case, the point cloud has been registered as well because I had several intersecting roads. So the point cloud has been, data set has been, the runs has been registered accordingly. And then making use of the utility module and also making use of some CAD LineWorks tool has been possible to create the utility network, which you can see here overlaid on top of the MX9 Trimble MX9 point cloud. And to make all of this possible, you can see here the utility module was used, and then we have the MSI manager, which is the material and site improvement tool, which gives you the chance to build up your library of items you are going to pick and to apply to your network. Then you have the chance to go through the creation of the pipes connecting, for example, manholes or different elements or nodes as they are called together. You have the chance to insert new nodes and then creating your template. And the template at the end, together, and the trench template at the end is this surface. Maybe I can show you like this. That's basically the 3D surface of the model that Trimble Business Center is able to generate. And in Trimble Business Center, you have the chance to compare, for example, this against the road or street level in order to create your volume computations or analysis. And these operations of trench and comparison against street level will generate in the end what is called the takeoff report, which you can customize at the change intervals. At the end, that's an Excel spreadsheet, which Trimble's Business Center is generating right now, where you have collected and organized in pages different kind of informations, like a summary, the length, some calculations about some cut and fill informations, right? It's quite detailed according to the change steps you have been configuring. You have a summary of the nodes, which was using two only kind of manholes I was creating and using in this example. And at the end, you have by change a kind of node takeoff report, which is providing you some information by elevation and volumes and things like that. So this could be a kind of final report that Trimble Business Center is able to generate, which could be used as a starting point to do some evaluations of the costs, which so the contractor is going to face when doing this kind of installation, opening construction sites for this kind of application. All right, so going back to the slide. So this was the use of MX9, Trimble MX9 dataset with the utility module in Trimble Business Center to do this kind of analysis operations. The 3D model, which is created when a trench template is applied to the mesh, can also be exported, for example, in Trimble Connect. And the interesting thing is that if the company, for example, owns some site vision kits, this 3D model can be transferred directly to the field with the site vision kit. And then it's possible making use of a augmented reality to visually check how the new installation, how the trench would look like in real, directly in the field. And once this model is on the site vision, the operator has the chance to do measurement mesh against reality, or doing measurement maybe mesh against GNSS position, because the site vision kit also is equipped with a GNSS antenna, so you can also make RTK GNSS measurement. And so from this point of view, the site vision can be the final step, the last mile, if you like, element of the workflow where you can really see how your project will look like in the field, right? Or maybe if some operations has to be done, some maintenance operation has to be done, maybe 1 year or 2 years after the utility deployment, then the operator can walk in the field and see and visually see on the display of vision, navigate to specific millage and say, or chainage and say, okay, in this location exactly here, maybe we have this element, maybe this manhole with this specific component, for example, optical splitter, which has to be revisited. And everything is kind of visible directly from the site vision without having to dig and search for this kind of element, or maybe without having to use this kind of additional utilities detector devices directly in the field. So this is a nice component which could kind of close the workflow for this fiber optic installation and management from this point of view. If you'd like to see or understand a little bit more how the augmented reality could help for this kind of in-field validation, we already did the webinar of the Mobile Mapping Essential series on how 3D model can be used in TBC, and then how from Trimble Business Center could be exported for site vision for on-site validation. So this link is recommended in case you would like to see or understand a little bit more of this possible workflow. Recently, we have introduced on our website page where we are talking about telecommunications and mobile mapping. So how mobile mapping, which technologies from a hardware, software point of view are supporting e-com applications. So if you would like to see read a little bit more of what we have in the portfolio available for this is the page you probably have to look at. What I am also recommending is having a look to the next webinar we are going to have, which is actually in 2 days, where in a Power Hour, TBC Power Hour, we'll show how MX9 dataset can be processed, registered, and used for corridor mapping in general. So yeah, don't miss it if this is the application, one of the applications you are also interested in using mobile mapping. So I think this is it from my side. I was anticipating 1 hour, but I'm a little bit earlier, 15 minutes earlier, so maybe we have time enough for questions you might have.
So, Marco, there were several questions I just realized relating to the audio at some point, but hopefully those resolve themselves. There's an interesting question asking about cost, Marco, and if we can give any advice to determine the cost of mobile mapping, kind of depreciating over 5 years. So I know we have that ROI calculator, right, that we could probably sit down with somebody and help them understand some preliminary costs.
Yeah, I think we probably provided, or if we didn't, maybe we can do our email connections, email contacts, in case someone would be interested in go do a deep dive on this. We could make use maybe together of this tool, right, to help on this topic specifically.
Yeah, so it was Stephanie was the lady that was asking. So I would propose that if you were to talk to your local Trimble person or Trimble dealer, we have a calculator. it's not obvious. It's not easy to answer your question just with a simple number because it depends on the application and which system and a bunch of parameters that need tweaking for your particular use case. But we have this ROI calculator that we could sit down with you and run through some of the variable parameters to try to get an estimate for you. Another question, Marco, is about Sight Vision and which GNSS system the Sight Vision system can connect to.
Well, the Sight Vision technology is basically consisting of a Trimble GNSS antenna. Maybe I can go back to the slide. Here, yeah. So you see, basically, this is running the software or the application, if you like, is running on a smartphone. So it's subscription based, the service which we do provide. And together, of course, you need to bring your own smartphone, and we are providing you this kind of holder, and which is also consisting of this GNSS antenna. Then the application can get connected to a internet RTK service provider, for example, a VRS network or single base based on N-trip technology. Then you can receive real-time corrections. There is a small IMU inside the system, so you just walk, you get corrections, you walk, you align your system, and then you are good to overlay your model on top of your camera, yeah, and stream the 3D model on top of your system.
Yeah, thanks, Marco. Yes, so whoever asked that question, yeah, the system is called Trimble Catalyst, I believe. And what happens is you basically use a mobile phone, and then we have a software GPS engine that you get an antenna from Trimble as well. So there's a small cost associated with that purchase of the antenna. And then the centimeter level service for your phone is a subscription-based service. So you can just buy for a month or 2 months or whatever you need and use that system for precise positioning. So one other question, Marco, could you tell us a bit more about the TBC utility module and how you get it and how it's supplied?
Yeah, so the TBC utility module is a module which has to be purchased together with one of the standard Trimble Business Center edition. So you have the survey intermediate, the field data, the survey advanced. So basically you need to have one Trimble Business Center edition and then adding purchasing the utility license on top of this. And what this is doing, well, basically, I think I was covering this during the presentation. You have the chance to digitize, basically, to create your utility network by starting with simple line works, basically digitizing, creating the geometry for utility network or runs, as this is called in Trimble Business Center. And then once you have defined the geometry, you can decide the elements you want to include into your utility network, for example, manholes, kind of type of manholes, where you are installing, at which height, respect to the ground, respect to the surface, which has to be the template of the trench you would like to build, where the utility line will be in, which has to be the clearances between the pipe and the sides of your trench. And at the end, the final result is this volume computations, which is happening, which is generated directly from the takeoff reports tool, which belongs to the utility module of the Trimble Business Center. If you want to know more, I think we have information on Trimble Business Center, in the Trimble Business Center metrics, where we are explaining the content of all the editions and the modules as well, which can be combined with the editions.
Okay, thank you, Marco. And then there was another question about the service for subscription service for Site Vision. So if you look on the service is called Trimble Catalyst. If you look on the Trimble website under Trimble Catalyst, and then the software piece of it is called Trimble Site Vision. So there's two parts, if you like. Catalyst and Site Vision are the two things you need to look for. Finally, Marco, last question. You mentioned about the TMX database and being able to connect to existing databases, existing schemas, use existing data schemas, add to existing databases, etc. Can you tell us a bit more about that and which systems you can connect to?
Yeah, in TMX, you have the chance to get connected to different type of databases. It could be SQL, Postgres, SQL, Oracle, Microsoft. And in TMX, from the toolbar, you have access to the preferences of the software, and from there you can directly go to the database communication. Once you know the parameter for the connection to these databases, then you have the chance to display and import the content of the pages or the tables of these databases, which means that if in the remote database you are connecting to, there is information like assets, like the manholes, you have already mapped the utility poles or power lines. All this information can be graphically displayed in TMX as a points entity, as a line geometries, as polygon geometries. But interesting is that you also have the chance to see in attribute tables, for example, all the attributes which are associated to the specific feature you are able to display in TMX. And these attributes are belonging to the schema, which is existing inside the remote database. And you can visualize those information, but you also have the chance to edit these informations. For example, if you would need to do the maintenance of feature classes or features belonging to feature classes inside the database, actually this is something you can do, because you can read the content from the database, but you can also write and update the content in the remote database directly, instead of working everything locally.
Okay, thank you, Marco. Sorry, I do have one more question that I just missed and picked up on. What is the repeatable accuracy of the MX7? That's the imagery-based system from Trimble in horizontal and in height.
Okay, so the Trimble MX7 is a mobile mapping technology, which in general we present this as a mapping grade accuracy. What does it mean? Well, the performances of these absolute accuracies are mainly the consequence of the kind of IMU, or inertial platform, if you like, we have in the system, and the GNSS conditions which the specific MX7 is having at that moment during the mission. The IMU we have is a kind of entry level, if you like, is an AP15, which is including the GNSS antenna plus MEMS IMU. This said, whenever you are in urban canyon or difficult GNSS environment facing significant outages, I would say that the performances could be sub-meter, half a meter, maybe something like that. It's really dependent on the condition of the GNSS coverage condition, let's say. What we do with the MX7 is we are post-processing the trajectory, okay? So the accuracies I'm talking about, this is post-processed final accuracies, which in many cases could be sufficient. In general, we have a lot of GIS service provider company, or let's say that the most of our MX7 customers are GIS service providers company. And the absolute accuracies we do have are matching with the application they are doing. Whenever there might be the need to increase the performances in terms of absolute accuracies, we are also offering the chance to make registration of the trajectory against ground control point. This would require the purchase of a new license or an additional license, if you like, of Trimble MX Content Manager, which gives you the chance to perform registrations of the trajectory against ground control. Now, this is very true in case you are working in GNSS partially or heavily denied conditions, but we have seen as soon as you are using the system in quite open areas, and we have a customer facing these situations. And in this case, the absolute accuracies are much better than that. We have seen customer with absolute accuracies being in the range of 30K performances, so a few centimeters in 2D and height. But this would be more the exception than the normal rule, I have to say. Okay. So if you're working on a pipeline project with no GNSS outages and you need to map some element there, yeah, then you are able to get these results because that's mostly coming from GNSS, right? Maybe the IMU part is not really contributing to this solution, okay? That's why you are able to get this kind of performances because that's based on the GNSS technology itself.
Okay, thank you, Marco. I think that was the last of our questions. There was just one other question asking if the recording will be made available, and it will, and a link will be sent to all participants sometime in the next 24 hours, I would say. So yeah, you'll get a recording link after the session. So thank you to Marco for an interesting presentation, and thank you all for making the time to attend this webinar. We look forward to seeing you at the next Mobile Mapping Essentials webinar. Thank you.
Thank you. Bye-bye.